Straight to the YouTube and trying to look it up.
I'm going to it right now.
Are you trying it?
Yeah.
Okay. About 8 more
What was
seconds.
the YouTube channel?
Oh. I don't know, but the channel name is my Google account. I don't know. My Google account is DAVSYL9.
Is what?
DAVSYL9.
Yeah.
Is it streaming?
I think it's, yeah, live now.
Right, you see it?
Yeah.
Okay, so it is
It's not on
recorded.
the stream now.
Huh?
It's stream.
You see, it should say,
On YouTube?
Yeah.
yeah, you should see,
I
CSCI 1933, 02/26, 2020, chapter 3. Just do a search on YouTube for CSCI 1933. Yeah, you got it. All right, about 1 more minute. Let everybody come in, y'all sign the room.
It's not secure. I need to just confirm on mine.
You did what?
Secure?
Okay, there it goes. I just got to speak.
All right, I do want to make sure, because sometimes it don't record, and then I'm doing the whole lecture and I can't post it. So y'all should be able to hopefully sign the roll now.
Wrong minutes.
Well, give it about another minute. Okay, I think last we stopped on was the math library.
The what?
Math library.
Yes, that stays roll. Okay, there.
Huh?
That's on the roll.
Okay. Right, that was it was between a couple of seconds different from us.
Did we make it to?
But I don't think we got what, but we got. Cause we did,
I don't know if we got that far.
yeah, cause we did the, this, we did the, what we did the plus. Alright, and these are operators. Combined operators, we did this is the plus, yeah. Alright, so, we just got, like, still, and remember books, what we did, remember when we did, typecasting? Huh? We knew typecasting? I thought this class was ahead of the other
I
class.
don't think.
We
Okay.
just got finished chapter.
You got it.
Huh?
Yeah, I think we had just started on chapter 3
Yeah.
the last time we were, or we got a little bit into it.
Yeah.
If we didn't get very far, I don't think.
Which one? That was out last year. Yeah. You're right.
Alan, how are you able to use the internet?
You gotta go to Edge.
James said use Edge.
It's in advance. I can't even log into the Wi-Fi.
Like, you have to set
Yeah,
your
I
Edge
had
to
this-
default
I had
web
this
browser.
on my list, but it was-
Alright, so, alright.
Oh, wait, you have to set your default web browser and select the Edge, right? So it opens automatically to it.
I use OpenEdge.
Good morning, Mr. Morning.
Morning, sir.
Yeah, it did for me, because I had to reset my, reset the default.
Alright, what I'm gonna do, first is go over
Just quick Google and.
the assignments that I posted for you, okay? And,
On my YouTube.
It shows it up there. It's like at
internet
LCTF
acting funny.
at edu.
They say they use, Edge, you know, say that Chrome and,
I like it be Chrome, because everyone just use Chrome. Some people
Right,
use Chrome
right,
more than Edge.
right. Alright, so let's look at this.
No.
what I did, I posted these assignments for chapter 3. And like I said, we're gonna continue with chapter 3. But look at these assignments, all right? This say write a C++, write a program, all right? Create and include your header file. Remember your header file, always do your header file. Remember to upload the CPP and the .h file, all right? So, it says click on the, click link below to download and or view program instructions or view instructions below. If you click here, it will give you the instructions, same instructions. You can download it. All right, it says write a C++ program that will allow a user to input, that should be 3, 3 integers, calculate and print the product of the 3 numbers, all right? And determine if the product is even or odd. Now, there's one function we're using, one concept we're using that we pretty much didn't go over. That would probably be the if statement, all right? But I'll kind of show you that. So, what happens, this is an example of how the program should work. Please enter the first integer. You're gonna input that or allow the system to accept it. Please input the second integer. Please input the third integer. So, now, you're gonna input those numbers, correct, class?
Yes.
Once those numbers are inputted, here we go, you're gonna output this statement. The product of whatever the first number is, comma, whatever the second number is, comma, and the third number, and then the word is, and then whatever that value is. So the question marks represent first value, second value, third value, and then the total, all right? So it tells you where the question marks are the integer values, and the 3 question marks is the value of the product.
Oh, so all that's the way you output?
Well, no, this is outputted because you what? Processing the
Yeah.
program. Once you input all 3 numbers, then you should get the following output. You understand?
Yeah.
But you got to get the first part, you know, and I'm just showing you what prompts to use, right? Sometimes I don't give you prompts, right?
Yeah.
So now, it tells you, it says, if 3, 5, and 7 is entered, you should output the product of 3, 5, and 7 is 105, right? But then, after that, you should tell me whether 105 is even or odd. Yes, sir.
Yeah, have you made these available yet, this program?
Huh?
Have you made the program available yet?
They should be, they're published, it's published.
I don't see it.
Huh?
I'm seeing it started program 3.
Right, 3 program, chapter 3, program 1.
No, the first one I see is program 3. I don't see program 1 or 2.
It's showing published. This is section 2, right?
I see chapters, program 1 through 4, yeah.
Oh, it is?
Right. Chapter 3. Look under assign module. Go to module.
So,
Yeah, okay, now.
Oh, you got it? All right. Yeah. So everybody understand that. So if it's odd, you're gonna say it's odd. Otherwise, this just else. This won't print out. All right. It's just explaining if it's not odd, then you'll print out the product of whatever is even. Right. So you're either gonna print out this output or this output. Make sure that you prompt the user for the input. All right.
is that example, we have to put that actually in?
Excuse me?
Is that an example, or we have to put like?
But that's the example. That's the example I want to see when I execute the program.
Okay, all right, that's the example.
Right. I want to see it go flow through just like that. All right. The next program. All right. Same difference. Same thing with the CPP and the header file. All right. It says write a program that will allow a user to input the information shown in the example below. Okay, from the keyboard. So we're still doing input from the keyboard. All right. employee's name, all right? Name should be first and last. Now, what's the key to that, class? From the last chapter. If I tell you input the first and the last name into one variable, what you gonna use to grab that? You're gonna use string, but how will you input it?
Is it under, like the,
What's the command you're gonna use to, because remember, CN will only read till the space. So what's the command?
CI.
Get line?
Oh,
No, remember get line, then CN in the variable?
oh,
Because if you don't use CN, it'll just grab the first name and continue on. Y'all remember the program we did in chapter 2? Where I did a program where you had to print out name, major, whatever, city, state, whatever. And then I told you to redo it where you had to read it from the keyboard, but you had to use the what? CN, because if somebody was from Port Allen, then what? You had to use the CN, the get line in order to read what? Up until the enter key. Remember that? So that's the key to this, all right? But then if you look here, then you want job title. Job title could be what? More than one word also. So you would use what? Get line again, right? But then here, you have employee wages. Would be what? What data type?
integer?
Okay, double. Because what? I might make 850, right? And then you can use CN. Then what? Hours worked, right? Which could be what? Double again, because if I work 8.5 hours, I want my 0.5 hours. Okay? So, once that information is entered, it says the tax deductions, which is 17.2%, all right? Calculate the gross pay, all right, and the net pay. So what? Given the information that you input, how would you get the gross pay? We're not dealing with overtime here. We're just dealing with what?
The wage.
Flat pay. So how you get the gross pay?
Hours time.
Hours time the wages, right? That's gonna give you a gross pay. But now, once you do that, now you gotta do what? Find what?
Deduct the taxes,
Deduct the taxes, which is how much?
17.2%.
Right. Now, you gotta understand that also. 17.2%, if you put it in a math expression, would be what?
Divided by 100.
You could do if you divide 17.2 by 100, what you get? Move the decimal place 2 places to the left. So you get what? 0.172. So you understand? So you can divide it, all right, group divide, and then do whatever, right? And then multiply, correct? Or you could just say, okay, 17.2% is 0.172. And then you find that difference, correct? And then you have to subtract from the gross to get the what? The net. So now you gotta do some thinking, right, class? Everybody understand that? Your math skills gonna come into play. But now you're gonna have some computer skills that gonna come into play. Because we're gonna go over some information to where I want the information outputted in this fashion. You know you're gonna have your header file, correct? But then I want a heading where you're gonna have name, all right, which is a title, and it's gonna be have a column width of 25. We're gonna go over that in the chapter, how we set our column width. Then you have job title, which is gonna be a column width of 30. Then you're gonna have wages, all right. Well, wages, hours worked, wages, hours worked, and taxes gonna have a width of 10. But then gross pay and net pay will have a column width of 12. All right, and we'll do all that. We'll show you how that is. All right, and then like I say, you got left align, right align. But if you look at this, all of this is what? Left align, correct? But all the words are what? I mean, right align. But all the words like name and title is what? Left align. but we'll go over that also, so you know. So you're gonna have to start programming to where you cosmetically fixing your output, okay? All right, so that's and this is just an example of how your output should look, right? Your header file, and then what? The heading that I want, and then the information falling under those columns.
Is the width, how many characters fit in that?
The width would be the number of characters that will be accounted for that output. So if I'm outputting, say, a number, 100, I could set the column width to 50, all right? So it's gonna take up 50 spaces, and then by default, it's to the right, all right? So that 100 would be the last 3 positions. I can set it to the left, the 50 spaces, and it'll be the first 3 positions. You understand? But only that can go into those 50 positions. Then the next output would be on the next one, whatever. All right? And that's how people space out the output. Okay? All right. The next one in C++. Same thing, header files.cpp, make sure you submit it. Write a C++ program that will prompt the user only once. Now, what's the key to this assignment is, I want you to do a multiple input statement. Everybody understand that? One cout statement that's gonna input this, and this. We're gonna go over that in the notes. All right, so it says, okay, let's say 5 scores. So basically you're gonna have what? CN what? Score 1, a stream score 2, stream score 3, stream score 4, stream score 5. Not CN score 1, CN score 2, CN, that's wrong. I'm taking off. Because I said what? Prompt the user what? Only once. What would your prompt somewhat look like? Please what? Please enter 5 test scores. You got me? I understand that. And this would be somewhat of an example of your input. A number, space, a number, space, a number, space, a number, space, a number, and hit enter. All right? Once you input those scores, it says all test scores must be displayed with 1 decimal place. All right? So this is how I want the output, but then I want the average also. So all output, well, you're gonna have a heading. I think I'll give you a column width. All right? Output column headings using a column width of 10. So if you're gonna do that of 10, you're gonna do the numbers, what? Of 10, right? Because they gotta fall somewhere under that column, correct? And if you notice, they all left aligned. Even though this might not show even, that's because of the character font. Don't worry about that. But they all left aligned. Everybody got that? They'll be left aligned. But these numbers gonna have 1 decimal place. Notice what happened. What was inputted here? 99, right? What was outputted? 99.0. So there's a way you can do that using set precision, and we're gonna go over that in the later on in the chapter also. All right. Now, so when you input the data, then you should output the headings, and then well, really you should calculate the average first, and then output your data. Right? Everybody got that? All right. So that's that program. All right. Then we have, I think, one more program that I gave. Now, this one, all you're doing is taking an algebraic expression and writing it out and solving it. All right. So what it says is, giving your header and your CPP file, write a C++ program that will allow a user to input values for the variables A, B, and C. Now this time I didn't give you any type prompt, so you prompted the way you want to, right? But you still have to input values, you know, and know that what's going into A, what's going into B, and what's going into C. All right. To solve the following expression, given that A and C are positive values. So what happens is, now you got what? What's this? Square root of B squared plus 4AC. So you're gonna have to figure out how to write that expression out in a statement so that you can calculate and solve that expression and give me the output. Everybody got that? And make sure you check your work. Just because you got an answer doesn't mean it's correct, right? Make sure you check your work before you submit it. Everybody got that? Any questions? 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 Straight? I'm gonna have my work? Huh?
Yes.
Oh, all right. Okay, so now, let's go back to the note. All right, and we know how to use CN, right? CN is accompanied normally by what? What statement?
Yeah.
CL statement, so that the user what? Knows what to input, right? You prompt it to know what to input, all right? So, but in order when you use a CSCI, you must include the what? That header file, what? IO stream, right? In order to use CN. Hello, Miss Russell. All right, make sure you do that. So look here, multiple entries, all right? Now, remember I told you I wanted you to input 5 tests at one time, right? So if you input 2 variables like this, CN, first variable, stream, the second variable, then what? If I wanted a third, all I need to do is what? Stream, and then the variable name, right? So as many variables that I want to input, I just keep streaming them into those different variables. Everybody understand that? So that part of the program that we had talked about, you should have that covered, right?
Yes.
All right? All right. And then what happens is, like I say, this was a program that was written previously where it was please enter length, CN length. Please enter width, CN width. But then they changed it around, please enter length and width. You got me? So you got one CN statement, and you input the first one, space the second one, no comma, space the second one, and then it inputs the value, and then it solves the problem. All right? So look here. Here's the CN here. You input them both, and then like I say, the problem is then actually solved. So CN, stream length, stream width. So now length has a value from this one, then width has a value, is actually calculated, and now you can print the area. All right? Okay. Now, I might have to make it smaller again. All right. Okay. So now, here, we have to be careful when we're dealing with keyboard input, all right? It says the enter key is pressed after the last number is entered on this part. So when we enter a number with your test 1, comma, test 2, comma, not comma, space, test 2, space, test 3, space, test 4, space, test 5, then you would hit enter. Now you could hit enter at any time, but the computer will still be prompted and waiting for what? The remaining inputs. Everybody understand that? So if I have that input CN statement where I have I'm trying to stream or input 5 test scores, and I type the first test score and hit enter, and the computer just gonna prompt go to the next line, and the cursor still gonna be waiting for the remainder what? Right, remaining 4. You got me? If I type in the second one, hit enter, it gonna accept it, but it's still gonna be waiting for the what? The remaining 3. You got what I'm saying? So you got it asking you for 5, so it's waiting for 5 different inputs. Once it gets the 5 inputs, then it's gonna continue. All right? All right, so look at this program here. All right? In this program, we have an integer variable called whole, a double variable called fractional, and a char variable called letter. Now, it's very important when you inputting data that you make sure the data is inputted for the proper data type. All right? In this example, they said here, okay, here, CN whole, stream fractional, stream letter. So it's asking for what? A int, a float, and a character, correct? Everybody see that? If I put in a whole number or integer, if I put in then space, a fraction, and then any character, right? Any letter or number is a character, right? Or a dollar sign or whatever. It will accept it and output it, okay? Give an example. Let's write this program. So what I'm gonna do, I'll go to online GDB, all right? And we'll quickly write something similar to this, all right? All right, so all right, so now if I say int, and what I'll do, I'll do it like this, so that we won't have all these lines on the screen. I'll just keep going across. But don't try to write code. Write your code line by line. Float and what it was, fractional. And then what?
Short letter.
Short letter. All right, so that's our three. Now I could have put them each on the line because I got semicolons, right? So I could have put them each on the line by themselves. But I'm just trying to save some space so you can see. So now I could just say, let's see. Oh, I'm hitting them. Okay. Wow. All right, so now, and I'll just inline this. And then I'll place it on the next line. All right, so now I'll do C in what? I'll do C in whole. And letter. All right, so now, once I input it, now I can output it. C out. And how I want to do that? I'm gonna just output the numbers. I'll just output the numbers. I'll do this. Whole. And I just put space in between. And letter. Don't matter about this. All right, so now, I'm gonna run the program. Hopefully I got all my errors out. Run the program. Now, it says, please enter a whole number. Give me a whole number. 4. Give me a fraction. 7.2. Give me a letter or character. Huh? All right. So when I hit enter, look, 4, 7.28. 4 went into what? Whole, correct? Everybody can see that, into that variable. 7.2 went into what? Fractional, all right? The fraction variable. And A went into what? Letter, the char variable. Everybody got that, right? Now you say, well, what's the big deal in that? Why is that important? It's important because if I mix this up in some kind of way, I can screw my input up, all right? You say how? It'll tell us in the book, but let's run this again. If I run this and I put 5.7 as whole, and what was that 4, and then 8. What would be my output? You all right, Ms. Russell? What would be my output?
It would be 5, 4.0, and then
Nope. Close though. Who else? What the first variable is that we receiving input into? The whole number. So it's gonna grab what? 5, okay? It's gonna grab 5, everything else stays in the buffer. Then I'm pulling in a fraction. What you think you're gonna pull in for the fraction? 0.7. So it's gonna take 0.7 and put in fractional. But then what is gonna put into a letter? What happened to the 4? If you think it's gonna skip 4, it's gonna take it as it comes. So it's gonna put 4 in letter. And now what? Your data is all screwed up, right? Because that wasn't your intent, right? So if I hit enter, look what happened. 5, which is a whole number, it took the whole part. Remember when we said that if we take a float value and store it into an int, what happens? What does it do? It takes the whole number and kind of like do away with the what? Decimal, correct? So what happened is with the buffer, it took 5 and then the read point was at the 0.7. So when it went to fractional part, it said, oh, I have a fraction, give me that 0.7. And it threw 0.7 into that fractional variable. And then now my read point is after the 7, and I'm gonna take the next available character, which is what? 4, which is gonna go in the letter. Now, the problem is if I was doing something with a loop and I was reading data, I done threw all my data off by 1. Whereas, and then for the first record, but for the second read, then for the third read, I done threw it off by 2. And then the next read, I done threw it off again. So now I'm having issues with bad data. You got me? And most times what programmers will do, basically when they're writing code in this fashion, they'll read everything in as char. As character data. Like say they might read in the 5.7 and check to see if it's, and then come do the typecast, check to see if it's in and whatnot, then might say what? Invalid value was in it. You got what I'm saying? Stuff like that. So that's how they would combat that. But just by inputting it this way, you're gonna have big, major problems, all right? Because what? Where's the A? The A is somewhere still in the buffer. It's something called cn.ignore, which is something that we're gonna have to start using, because when you go from numbers to characters and back to numbers, you still have information in your keyboard buffer that you have to do away with in order for it to start reading fresh again. All right? So make sure when you inputting values and their various data types, make sure they match. All right? Make sure they match with what you input, because you can screw up your data. All right? So we go back here, then it tells about the keyboard buffer. So now it says, okay, if we put in 5.74 in B, all right, what happens is it's gonna read in the 5, just like we said, the 0.7 gonna go into the second variable, and then the 4 gonna go into the third variable, which is the char. Okay? So that is what would happen. So you don't wanna get into that kind of situation, because that can be mind-boggling. All right. So now mathematical expressions. We know how, and we said that what you always solve on the what, on the right, and what assign to the what, left. Always, always, always. Remember that. Always. Your expression could be whatever. X is equal to 5. But it cannot be 5 is equal to X, because 5 cannot be overwritten, right? So you always solve on the right and assigned to the left, right? And if we look at this, on our left side, we have a variable called sum that can be what? Overridden. So sum is equal to 21 plus 3, right? So it solved this, which gives us what? 24, not 20, yeah, 24, and then it stores it into sum, right? Solve and then store. Same example here, number equal 3. There's no expression, but it's taking a constant and storing it into a variable, all right? It could be a variable here, x equal results. Whatever stored in that memory location for x is being stored into what? Results, all right? And same thing, at 4 being stored in the results. This expression stored in the results. This expression results is stored in the results. Remember this? Size of, what would be the value stored in the results here? What size of gives us? The size in bytes that we can store for that variable. What was the byte size for int? It was 4. Remember, short was 2. Remember, int is 4. All right. So 4 would be stored in the results. Here we got a plus b plus c. All right, results is equal to that. All right. So you always solve on the right, assign to the left. All right. So look here, numerator, denominator, all right? Here what happens is, they just took, now we don't normally teach you to code that way, but it's not wrong to do it. But normally when you solving something, you may need it for later use, all right? And that's why we tell you to, don't just put your expression as the output, right? But it's not wrong. But if you look here, we enter the value for a numerator. We enter the value for a denominator. But then what we said, see out numerator divided by denominator. It's gonna give us a result. Rather than store it into a variable, it'll give us the result. Now, it could come into play where if you're coding and you want to reduce the number of variables, which would kind of help you in your programming scheme and the speed or whatever, then you might want to do this. But many times when you calculate something, you want to break it down in a short interval, so when you make a mistake, you could go back and say, oh, I made a mistake here. Because if you got a long drawn out expression and you're getting the wrong answer, you got to continuously go through that whole expression and try to figure out where that problem went wrong at, rather than have it broken down into separate pieces. All right. But as you become proficient in programming, you might want to just have one large expression. All right. So what happens? You input that, and look, you got 6. All right. I mean, 0.873. So what I can do here, I can actually show you what happens. So if I did this, I had whole and fraction. All right. And I did something like int total is equal to whole times fractional. All right. Then here I could say see out yeah. Oh no, I didn't want to do that. I want to take this. I don't want to create a variable. I just want to take this. Right. All right. So all right. So what I did here, I just said, okay, total, I'm printing out fractional time whole. I mean, whole times fractional, all right? And get a result. I'm not storing it into a variable, I'm just printing out what that is. So when I run this program, all right, if I put in 2, and then I'll put in 2, all right? Being that it's a whole number, and I'll put B, all right? It's at the top. Let's see. See, total is 4.4. You understand? Whereas I didn't create a variable, I just said print out for whole time fraction, right? So it just printed out that value. All right, everybody understand that? All right, and that's the this one here, print out whole fraction on letter. All right, now, any questions? All right, any questions? Order of precedence. Now, we know that in math we have what? Addition, subtraction, multiplication, and division, correct? But in C++ we have one other operator, which is what? That percent sign, which is what?
Modular.
Modulus. So the thing is, addition and multiplication, division, and modulus are on the same, has the same precedence, and then addition and subtraction is below that. Everybody understand that? We just had that one extra, that modulus. So we know that what? If we could look at this, everything is addition. So we just go from left to right and add, right? Here we have outcome is equal to 12 plus 6 divided by 3. Nothing is grouped, so what? We have to do the what? Division before we do the what? Addition, right? Now, we might not do it by looking at it, but the computer will do it automatically. Everybody understand that? So you have to know how the computer will execute or implement those expressions, right? Because we might look at it and say, well, 12 plus 6 is 18 divided by 3. Well, we get what? 6, right? But that's not the answer, right? It's 6 divided by 3, and you're gonna get 2 plus 12, which is 14, right? So you've got to be aware of how the system will evaluate the expression. Now, and if you look at this, it just tells you, you're gonna divide, you have to divide first, then add. So, here's our unary negations, which where you have the multiplication, division, and the modulus. Remember what the modulus does?
Yeah.
What it does?
The remainder.
Give you the remainder. So what is 10 modulus 4?
2.
2. 4 going to 10 how many times? Twice, which is 4 times 2 is 8. 8 from 10, got a remainder of 2, right? Everybody remember that. So the modulus gives you the remainder, all right? Now, all right, so this is the precedence. This have higher precedence than adding and subtracting, okay? Just remember that. So when we look at this, what we're gonna do first here?
2 times 4.
Multiply 2 times 4, then add 5. What are we gonna do first here?
10 divided by 2.
Divide by 2, then subtract. What we gonna do here?
12 times 2.
Multiply 12 times 2, then add, then subtract. What we gonna do here?
Modulus.
We do the modulus, then we're gonna add, then we're gonna subtract. What we gonna do here? We're gonna multiply 3 times 2, then subtract, then add, then subtract. Right? Everybody got that? So now, since you know the precedence and you know how it works, now we have another rule that we have to comply to, and that's when we group things, right? When we group things, we have to work from the inside of the parentheses outward, right? So looking at this, 5 minus 3 plus 2, they both on the same precedence, we'll get the answer. Here we got 5 minus 3 plus 2, but it's grouped, so we must do what? This first and then do this, right? Looking at this one, we got 12 divided by 6 times 4. We do the division, then we do the multiplication. But look here, we have to do the division first here because it's grouped, and then we do the multiplication, all right? But it's like the same process, but it can change, all right? It can change, all right? So now, here we go where it shows the operation left to right, and the negative is right to left. All right? Yes.
Dividing using brackets.
You don't use brackets. Talking about the square bracket? No. Everything is parentheses. Right. How would I say it? Yeah, parentheses. Brackets in C++, if you ever, well, when you get to 194, or maybe later on in this class, you're gonna see where brackets, they have a use, but they're gonna be used for subscripting arrays, all right? Subscripts of arrays, all right? What you mean by that, Mr. Sylvester? What I mean by that is, and I'll just show you a little bit of what I'm talking about. If I create an array variable, I could say int test here. When I do that, that says that I have a variable called test that has 4 different elements in it, integer elements in it. It's an array. Those values, whatever values I put in there will be contiguously placed, all right? So I can retrieve those values. Now I can do this, equals, now I got curly braces, 10, 20, 30, 40, all right? Now, you say, okay, Mr. Leslie, you say it's 4 array positions, okay? Now, when you're dealing with an array, we know we have 4 what? Elements, correct? 4 positions. The computer, okay, if I ask you to start counting for me.
1, 2.
All right, now what number he started with? And that's normal for what? Us as humans, right? Computer science, or the computer starts at
0.
starts at 0. So, if that's the case, being that I just told you that, what you think the first position will be? 0. That's the index of 0. What's the second? 1. What's the third?
2,
And the next?
3.
3. So, if I did this, if I did something like this, see out, test array, right? And then I'll say test sub 2.
So I'll put the 30.
What will it print out?
30.
Huh?
30.
30. 0, 1, 2. Right? Even though I got four elements, I told it to go to the what? The second element and print that second element. So when I run this, okay, let me put in see? Look. Print it 30. Everybody see that? So I can choose whichever element that I want to print from 0 through what? 0 through what? 0 through what? 3, remember? 0 to 3 is 4, right? So I can print any one of those. But that's why the brackets come into play. But not when you're doing the expression. Now I know in math you might do it, but this is computer science, right? You have to use those parentheses. All right? So that was just a little something on arrays, which you're gonna get to later on. All right, so now, when we look at this, results equal A plus B divided by 4. Now, even though division has higher precedence than addition, what we must do first? What in the parentheses, work our way out, and then we eventually what? Divide. Okay? Everybody got that? Everybody understand that? So if we look at this here, what we doing first here?
5 plus 2.
We adding the 5 plus 2, then we multiplying. What we doing here?
5 minus 3.
Doing the 5 minus 3, then we divide that into 10. What we doing here?
6 minus 2.
Right, you do the 6 minus 2, then what we do?
4 plus 17.
No! Oh, I'm talking about here. We still ain't finished. What we do there? Next.
You're gonna multiply.
Right, you multiply, then add. So what we do here?
You're gonna do 4 plus
17, then what we do?
Modular.
2 modulus, whatever we get here, and then we minus 1. What we do here?
6 minus 2.
All right, and then 2, then
D multiply.
correct. And then you divide, correct. That's right. All right, so that's how it works. Now, look at this, class. Remember I gave you that expression to solve? Right? That square root of whatever. You as a programmer will, and like I said, maybe with assistance from whomever you're working with or whatever, like somebody in chemistry, whatever, however. But you as a programmer will have to write out your expressions. If a chemist give you a formula, you would have to know how to write it to put it in the program, correct? So, looking at a mathematical expression, 6b is equivalent to what? 6 times b, which in C++ is 6 asterisk b. 6 times b. Everybody got that? 3 in parentheses and 12 in parentheses in math is like 3 times 12, correct? So in C++ is 3 times 12. But then look at this, 4xy. In math, we understand that that's 4 times x times y. But in computer science, we'll have to do 4 asterisk x asterisk y. Everybody got that? Everybody see that? So now, I'm gonna ask you this question. Looking at this counts the square root part of it. The first, this part here, how would you write out this in an expression?
4 extra is A, extra is C.
Right, 4 times A times C, correct. Now, that should be what? Grouped, you can group it. I would group it because it's on this side of the plus, and then I have this just to kind of make it a little more clearer. You know what I'm saying? But you don't have to because what? The precedence of this and the precedence of this overshadows this, right? Right? But you just need to make sure you write it out correctly, right? Now, all right, so, and like I say, it gives more examples. X equal A plus B over C. Look how they would write it in C++. X equal what? The grouping of what? A plus B, all divided by what? C, right? So you see, you gotta kind of understand how the expressions are solved, right? So that you can write it into the C++ expression. So here you have different ones here. Hey, look at this last one. 3xy plus 2 over 4a minus 1. So all of this is divided by 4a minus 1. So you got all of this, 3x plus 2, all of this divided by 4a minus 1. 4 times a minus 1. All right? Questions? So everybody see how you can break down those expressions, right? All right. Now, here we have a new function introduced called power, right? Now, power can be used, but before you can use power, you have to load, you'd have to load a library, and the library, is that right?
H, right?
Well, yeah, you can do the .h, or because we are not using a wide variety of functions, yes. But if you want your program to run on all platforms without any error, you'll do the CMAT. All right? But both of them will work in this setting. All right? But sometimes when you move it to another platform, the mat.h may not work.
What do you mean?
Depending on the compiler.
What do you mean another platform?
Because
Like some.
it might not load all of the libraries. It'll load some of the functions in the library, but not all. All right. So if I do mat.h, it'll pull in libraries, but maybe not all. It'll pull in libraries from the C compiler. All right. And C and C++ is closely related. But if I do CMAT, I'm pulling in all of the C++.
Oh.
You understand?
Yeah.
Right. So that way you won't run into that issue. All right. So when I use CMAT, all right, and I'm gonna go back here and show you. All right, power. Look how they use power. Power of 4.0, comma 2.0. What is it that actually doing? That's taking 4 and raising it to the what? Second power. So that's what that function does. It returns it to this. So 4 squared is what?
Or 16.
16, right? 4 times 4 is 16, right? And it stores that into array. So let's look at that expression. So if I do something like I'll take this. Where is it? I'll say, and I'll do this like this. Power test 2, comma 2. All right. So what that should print out, class? No, not 2. Yeah, that's 2, but I'm gonna do 1. 0. So what that will do?
100.
Correct. I've taken the value of test sub 0, which is 10, and raising it to the what? Second power, which is 100. 10 squared is 100. All right. So when I run this, see, test array 100. So it took the value at test sub 0 and raised it to the second power. All right. So and you could use any value here. You could put a value here. You could put a variable. I could have put whole right here, and the whole raised to the second power would have gave us 4. You understand? So whatever value, it will actually raise it to that power. All right. But if you look here, power is not the only function that is used. All right, let me see if it did a constant. Oh, I don't know if we went over it, but I'm gonna go over it now. Look here. They have an expression. Area is equal to pi r squared. Pi we know is a constant value, right? Which means in math, 3.14, and it can be a little longer. So what they did in this program here, they said, okay, we know that pi is constant. We don't want it to change. If ever we use it in our program here or anywhere else, we don't want pi to change, because that can change what? Our values for everything. Circumference of a circle, square, area of a circle, whatever. So we know pi is 3.14, 159. So what they did, they just added that small word, const, C-O-N-S-T, that command. What that does is, okay, whenever I use pi, it will not change. If I try to say pi is equal to 2, or pi is equal to 3.14, pi is equal to 1, pi is equal to anything, I'm gonna get a violation error, all right? Because I said it's constant, and it's equal to 159. So if I try to change it anywhere in the program, I'm gonna get error, all right? So that's what that constant does. And that's when you know you have a value that you don't want change. Kind of like with the bank. If you know your interest rate is a particular interest rate, you set that interest rate, and throughout your program, wherever you're doing interest, you don't have to go in each statement and change it, because you changed it and gave it a value at the top, made it constant, and it will not change as long as the program runs. You want to modify it, you make the changes, then implement that program again, and now it's going to change to something different. All right? So once I run this program, pi cannot be changed from 3.14. I will get an error. And to show you, okay, I could say anything. T is equal to 22, all right? But then if I go down here and I'll say, just say T is equal to 5, all right? Watch when I run this. Look, error, assignment of read-only variable T. because T is constant, I cannot, even if I try to make it the same as what it is. If I say, okay, but it is 22, I'm just trying to reassign it to equal 22. But the violation comes where when you're trying to change something that you said is already constant. You got what I'm saying? So that's why why you get the error. All right? So you gotta watch that. Now, all right? So that's what that program did. Y'all go through these end of the chapter questions. Now, when you mix apples and oranges, all right? Conversion type. Here we go. You got long, double, float, unsigned long, all right? Long, unsigned, int. Now the unsigned, what that says is that what? My value will always be what? Huh? Unsigned means my value will always be what? Positive. Okay? I'll never have a negative. Like if I multiply something 5 by a -2, and I'm storing it into an unsigned int, I'm gonna get a positive because the sign, it says unsigned. I can't, it's almost like an absolute value, right? I'm getting absolute value. So it cannot be a signed value, all right? So it tells us one exception for ranking in table 1 is when an int and a long are the same size, all right? In that case, the unsigned int outranks the long int. And what the ranking is when we dealing with division and whatnot, you have promotion and demotion, all right? Or you have promotion. And what happens is, I'm gonna have to erase this. I'm gonna take all this out, class. All right. If I do something like this, I say int x equals 2, y equals 3, total. All right, so if I do something like this, total, oh no, I'll do double total. If I say total is equal to x divided by y, all right? What am I gonna get, class? What you think the answer gonna be? What's 2 divided by 3? Point whatever, right? But 2 is what data type? X is what data type? Y is what data type? So whatever's on that side of the expression will return a what type value? Int value. Might understand that. So that expression will return an int value. So what you think will be returned in the total? What's the inner portion what's the integer portion of the result? 0. All right? So when I run this, if I do C out, if I can type, and you're like, man, what's going on? Why does it give me 0? 2 divided by 3 is whatever. See? I get 0 because I had an int being divided by an int, which yielded an int result, and that int was actually stored into that double, right? Which was 0, right? Which is 0. Now, if I take this and I say, okay, I could either do it 2 ways. I'll do it this way first. I'll do if I could take. I'll do this. I'll change just to double. Or either float. all of a sudden, well, still I need to, no, that should work. It might. All of a sudden, now I'm dividing a what? An int by a what?
Double.
A double, which promote my expression to a what?
Double.
Double, which returns a double value. All right? So when I run it, see, I got my 0 point whatever. So you got to be mindful of the data types and what's going on that expression side so that you what? Can get the actual value that you need. Otherwise, you're looking at me, why is it giving me 0? What's going on with 0? My expression right, my this is right. It's got something to do with your data type and promote it. Give you another example though. If I do this, if I simply say x, I'll just do 2 and 3. 2 divided by 3, right? 2 is a what? Integer. 3 is a what? Integer. So if I divide 2 by 3, what the total gonna be? 0. Yes, sir.
Mine's giving me errors. I did that. I think I did the same.
With
thing.
what?
It's saying expected unqualified ID before double.
For what?
Before double. The y equals 3.
You got double y equals 3. Do you have a semicolon at the end of x equals 2? Okay. Yeah, remember I had to go back for mine. Remember? All right. So if I run this, it's gonna still give me what? 0, because int and an int, it's gonna give me the 0. Now, all I need to do here, I could do this. It's right here. I could do. If I do this, what happens? Now I'm dividing an int by a what?
Double.
A double, which does what? Promotes my expression. Now I can store that double value into that double variable, right? So now when I run it, now I'll get my whatever. Right, to see that? And I'm telling you this because in I think one of the programs I gave you, some people gonna have those integer values and they're gonna be divided by 5, if that's the one, or they're gonna be divided by 3 and like I couldn't get it to do a decimal. That's that promotion. If everything on the left side, on the right side is int, y'all saw all you're gonna get is an int. All right, so you gotta be mindful of that. All right, so that's basically what this is telling you. So that will be promoted, all right? And it talks about promotion and demotion, and you can read that about promoting, all right? Now, integer division, basically what we just talked about. This divided by this is gonna give us a what? Return a what type value? This is int, this is int. But return an int, right? Float int, gonna return what? A float, all right? So you got to be aware of that, all right? And you're trying to find the answer and you're looking for that decimal place and you're like, what's going on? That's because your data type, all right, is not being promoted to the right data type, all right? All right, overflow and underflow. Now, remember we talked about byte sizes of our data types? Now, this little program, what it shows is, it gives you an example of the short data type. Remember, short data type had a range of values that can go into it, and that's it. I don't care if you wanted, the largest value is 32,767. That's the largest value that can be stored in a short variable, period. It got a minimum range, but that's the highest range, right? If I add 1 to that number and it's short data type, it's gonna revert back to the beginning range, which was negative whatever, and start again in increment. Everybody understand that? And that's what this program shows. So let's take this number, all right? So I'll just take this and put in the program, all right? I'll copy this, and let's go to the program. And I'll go here, and what I'll do is, I'll paste this, all right? And this is basically what the program is doing. And I'll just say, Tell you. Alright, so everybody, what happened here? What did I do here? And we're gonna get to this in a little while too.
You declare a test variable and then
Right, but what did I do right here?
plus you just add.
I just added 1 to it, that's all. This is equivalent to saying test var is equal to test var plus 1. Anytime you see that plus plus, you add 1 to it. That's all. Minus minus, you're taking away 1. All right? So I added 1, okay, as I'm short. Now I'm gonna print all right. So what should our output be?
-3, 2.
Correct. When we run this, it's gonna add 1, but what happens is it's gonna go back to the starting point and come forward. And the extreme low value is a negative 32,768. You got me? Even if I add 2 to it, all right?
Does that step out of the range? And does that show you that you exceed the range because it steps out of the range? Because is the bottom range negative?
Yeah, it is. This is the bottom range. See, it only can.
Is it the bottom range plus the 1? Plus the -1?
Plus 1. See, when I added 1 to this is the beginning. That's the lowest value that can be stored and displayed correctly in that variable.
So, okay, what if you add 2? You're about to do it.
Add 2, it's gonna be a negative 32,769. See, it's gonna keep going back up till it get to the extreme and start over again. You understand? It can only stay in between that range. All right, let me show you.
So it can go infinite in the negative?
Let me show you. Remember, if I could find it. Yeah. Remember this? Short.
Right.
This is the lowest value that can be inputted in.
Okay,
This is the highest value. So if it goes beyond this, it starts back over here incrementing to get to that point. You got me? Everybody see that? So your expression could be correct, but it's just your data type can't display the value, the correct value. You got me? So that's something you got to be mindful of too. Make sure you understand data types and the range of values that it can hold. All right? And these are the different ones. All right? So when I go back here, all right, and I can do this. I'm in the wrong place. Here. And then I'll do this. Right? So both of them is equal to the same, right? I'm gonna increment that one and then right? So let's run, I need to output it. All right, so when I run it, see what happened here? Our values were this, all right? Both of them had the same value, correct? This incremented by 2, but it went what? Negative 32,767. So it went down. 68, 67. And then this one, this was 67, added 2, 69. So this gives us the correct answer because what? Int is able to go beyond that value. You know, the side, this particular value.
Oh,
Yeah.
so it wouldn't be 69, it would be 68 plus 1. Like, so that goes that way on the negative.
Right, it's going to the negative, right,
Okay.
right. Alright,
And is it the same, is it the same as, negative 32768? And if you minus 1 from it, it'll go back to the.
right, it'll start trying to go back, right. If I do a negative, it'll try to go back, then it'll flip back to the positive side, correct. That's what happened. Yeah, because that's the only values it can display, you know, and it's just gonna stay in there. It's almost how you take a clock. You know, you can only go, if you're going forward, just go to those numbers. That's the only values that it has. And that's somewhat like what this is. That's the only values it can hold. Forward or backward, same, you know, same values. All right, now, so, and like I say, that's the output we got or whatnot. All right, so now, then it talked about, well, this shows you scientific notation. Well, this is overflow 10. But still overflowing on the flow, because you won't get the right value. But typecasting, what it does, it allows you to take a variable of a certain data type and use it as a different data type. Remember how we did letter, and we had letter equal A, but then we assigned letter to an int variable, and we printed the int value, and it was what? 65. Typecasting can do that. So if you have a variable called letter and it's charged, you could typecast it to be int, use it in an expression, and then move on without changing or doing anything with the damaging the value of the variable. So that's what typecast. Or you could have an int value. Remember when we just had to promote our expression? We could have an expression where we have all ints, but we could typecast something to be double rather than trying to change it to double. We could typecast it to double, divide it whatever, and get whatever. And it's gonna promote, and without changing the value, all right, of that variable store. All right, so, yes, sir.
So is that saying we don't have to use PAL right there? They just did 2.0 E, so exponent negative 38. Is that what they did?
Right.
So you don't have to use PAL?
Use what?
PAL?
No, this is not power now. This is e-notation.
Oh.
You understand where that decimal place is what? 38 spaces to the right. So that's a very long, a 38-digit number. You understand? E to the 38 means that number goes, the decimal point goes 38 to the right. So you know you can multiply stuff easily with e-notation rather than having to write out all the numbers or whatever. All right, e-notation. If I had to multiply 5 billion times 6 billion, rather than write out those numbers, I could do 5e whatever times 6e whatever, and then get 5 times 6, and then just add the exponent, and I'm done. So that's basically what this is, right? And so that's what happened. All right. So now, typecasting. All right. Typecasting. If you look here, they assign something to be of double. All right. Number is what? 3.7. Then they created a variable called val. But what did they do? They took a number, typecast it into an int, and stored it into val. And now you can use the val part, the int part of number, right?
Yes.
Everybody see that? And sometimes you may have to or need to do that based upon what you need to do in your program, all right? I just need the whole number part. I need to do whatever, right? So you could typecast. So when you do a typecast, you do static underscore cast, the data type that you want to convert to, and then the variable. So it's going to take what? 3.7 and what? Convert it to int, which is what?
3.
3, and it's gonna store in the val what?
3.
3. All right? Everybody see that? Okay? All right. Now, look here. We have a program where we have books and then months. They're trying to find the number of books per month that a person reads. So, the number of books, you only read, when you turn it in, you're reading in a whole number, right? You don't go ahead and say, well, I read half of this book. You might not get credit for it. So it's the number of books, so that's in. Number of months, that's in. Okay, per month, now that's double. That's kind of like our 2 divided by 3 stored into a double, right? So what they did, rather than have to take the one of the variables, make them a double, what they did was, per month is equal to static cast double books. So they just took books and converted it, static cast it into what?
So,
A double. So a double divided by an integer promotes the expression to what?
double.
To double, so that it can store that what? Decimal place. So when I read 4.28 books based on whatever value they put in. Everybody see that? So you can actually use that to promote your value rather than trying to create another variable and do whatever and all that. All right. So in many different ways you can use static cast. All right, and then static cast, sometimes like when you're dealing with letters, like I say, letters have numeric values. And then you might want to do something with the numeric value of a letter. Static cast, right? And then you got it, all right? So how much time we got?
It ended 5 minutes ago.
Oh, okay, all right. All right, so you can get started on your programs. We're gonna continue. If you wanted to work on your that last program though, well, we're gonna go over this too. But that last program, that's gonna come in with format here, format your output. We're gonna get to that next class period, and that's gonna deal with you're gonna have to have another header file loaded called IO-man IP, and then you're gonna have set W, which is the set the width, and then we're gonna deal with set precision. And then the show point, okay? See the IO-man IP? That's the header file that you gotta load, all right? And look, set W and stuff like that. So we're gonna get into that on next class period. And start on your work. And like I say, bring questions to class if you got them. Because I want my assignments class, right? Hello? All right. Now you know you got the ALC. You can go to the ALC. And we also have CUSA, which is a 3rd floor in the library, okay? All right, have a good one.